Dear student, so in previous video I have talked about the turning effect of force. So if you have not watched it, please go and watch, then it will easy to understand and you can link off. So where I explained you that what is the meaning of turning effect of force. If you know, the force will give you a change in shape. Okay, whenever you apply the force, there will be multiple thing can happen. Okay, it can cause the shape of change of the shape. Okay, it can lead, if something is moving it will stop, if something was stopped it will start moving. This is another effect called turning effect of force. It means when you apply the force and if something is hanged at a point, that will be show you the turning effect. So in this video I'm going to talk about principle of moment. What is moment? Moment is your turning effect of force. Turning effect of force. This is also called torque. Okay, so let's understand. If an object is not turning, it means what? You know what is the turning? That if you play the seesaw, right, the playground, if some student boy is sitting here, obviously it will start turn this side, but since there is a ground, you will not go again this side, you will just follow it here. So to balance this, another boy stand it here or sit here and try to balance this, and then what happens is completely balanced, because whatever force moment, I should say the moment is applying by this person, the same turning effect applying by the boy B2, and finally there is no turning, it's completely balanced. So can I say if an object is not turning or if it is in equilibrium, then total clockwise moment, so this boy will move clockwise about the pivot point, which is this, will be equal to the total anti-clockwise moment about the pivot point. Okay, this is very important and it will help you to solve other question. Now let's see example what we use every day when we purchase the grocery or fruits from the market, right? This is what we do, that on the beam balance, a person put a standard mass to this side and what we want to weigh this side. Now if your weight is balanced to the standard mass, this will not show any turning, right? It will not turn it. So at this condition where you have equilibrium condition reached, right, it means what? Here the moment of force will be same. It means mg into d will be your the standard mass, which is written here 3sg multiplied by d. Since d is the same, it is going to cancel out and you will see that your mass is basically 3s. Okay, and in this way you can figure out the force, and this is very simple calculation. So what we have learned, that whenever something is equilibrium means it is not turning, it's balanced, there are two conditions it should be satisfied. So this is two important conditions. The first, the resultant force on object is a 0. What is the resultant force? The force with the direction. Suppose if the one block is moving, applying the force 5 Newton this direction, if you pull or push with the same amount of the force in opposite direction, this block will not move. So in this condition what I will say, resultant force is 0. Okay, similar thing you have to think about here also, that if this is a pivot point, if this is applying the force 10 Newton, so this should also apply the force in the 10 Newton, so there has been no movement, right? Okay, because you are looking here turning, so then and then only it is not going to show you anything. And second thing, the resultant moment of an object is the 0. What is moment? Moment is basically that the force into perpendicular distance, which I said d, should be 0, then the resultant moment will be the 0. Now let's understand with some of the question. So how to solve this question? Read the question carefully, pause my video, try to solve it by yourself. I hope you already solved that problem. So let's read the question again, that a uniform meter rule balances horizontally about a pivot point. Okay, so this is a meter rule. Okay, this is a pivot point at its midpoint, as you can see 50 centimeter when the weight 10 Newton is suspended from 20 centimeter mark, another weight is 8 Newton is suspended from the position R as shown in the figure. The moment of 10 Newton force about the pivot. So what is the formula of moment? Moment is equal to force into perpendicular distance. How much force? 10 Newton. What is the distance of pivot and this point? As you can see, this is the total 50, this is 20, so this will be your 30. Very important, whenever you calculate such distance, you should be very clear in your mind you are calculating from where to where. And another thing, it is written in centimeter, so if you are writing in the SI unit, it will be converted into the Newton meter, which is now it will become your 3 Newton meter. And what is the direction? It will be anti-clockwise direction. Anti-clockwise. Okay, done. Now question number B, the position of R where 8 Newton weight to be hung such that the rule remains horizontal. Rule remains horizontal means what? Remember, this is a condition of equilibrium, means the moment of 8 Newton is equal to the moment of 10 Newton. It means what? It means anti-clockwise. Okay, I'm solving the B part. Anti-clockwise moment will be equal to clockwise moment. So anti-clockwise moment is the 3 Newton meter. Clockwise will be how much? 8 multiplied by, what is the difference? It is the 50 and this is your 100. So if you think about total from here to here, this is what they want. So what should be the position? It means you don't know. This is what we need to figure out. So D2. So if I want to know D2, it will become just 3 by 8, which is 0.375 meter. That's it. I hope you have also got the same answer, right? So let's see next question what you have. So sometimes question look difficult, but actually it's not difficult. We have to just make some map or some diagram and try to fit what we have just now learned. Let's see question number this. So figure 5.9 show a hand winch. Okay, the hand winch is used to move a load. You know, this is the hand winch what is used to move the load, any kind of load. And what is the minimum force required to turn the drum? Okay, again minimum force means what? Suppose if this is the pivot point, okay, if one boy is sitting here, so if I'll ask you what is the minimum force required to balance it, right? So you will say if this is around 40 Newton, no person, and this is D same, so you'll say I should put the same amount of weight to this side. That is the minimum, you know, it is required. If you give more or less, it is going to obviously change. So minimum force to turn is what they are asking you. It means what? Again you have to think about the same principle. Okay, that principle of moment say that what? The moment, so I think you should write in a better way, sum of clockwise moment, right? Clockwise moment caused by this force and the load what is we are looking should be the equal, right? The moment of the force caused by the, so if they have given you so complex figure, whatever based on this information, maybe we should make some rough diagram. Okay, it will clear our all the doubts. So one force is in this direction, okay, then load you have in this direction, which I am writing with L. This is your force. Now where is the pivot point? So this is the axis of drum. It means at this point you are moving it. So this is your pivot point. Okay, this point which I have put here in the red. So if you have to think about this distance, it is how much? It is 0.1 meter. And if this is the pivot point, and they have already given you the distance from the pivot side, so this is the whole, you have around 2 meter from this data. correct. So now you have enough idea, okay, that this is the pivot point, here is the load, okay, and when you put the, when this is the load, this is how much you have to turn it out. So let's figure out what is the, if you think in this direction, what will happen, this will move to the anti-clockwise direction, right, and this will move to the clockwise direction. So please solve this problem and let me know in the next video how much of them you got correct. So in next video I'll talk about this video and the next video. Thank you so much.